Okay, so for the final part, I'm going to be taking a look at how to graph a quadratic in vertex form. So first of all, we have the equation a parentheses x minus h squared plus k. A would represent our vertical stretch, h would be a shift left or right, and k would be a shift up or down. Our vertex would be at h comma k. Remember, whatever this value is inside the parentheses, you have to change the value, or you have to switch the sign, specifically when it says switch the value. And then the final thing is our axis of symmetry would be x is equal to h. So our first problem we have x plus 2 squared minus 1. So my vertex, I can see 2 matches up with the h, and I have to switch the sign of it. So positive 2 would become negative 2. My k value is negative 1, and it did not say to change the value of the k value, so I'm going to leave it as negative 1. So 2, negative 1 would be my vertex. My axis of symmetry, it says is x is equal to h. So I got to remember I need to switch the value of the sign of h. So h was positive 2, so axis of symmetry would be negative 2. The next thing I need to know to graph my quadratic is I need to remember my quadratic pattern. So my x values, or my horizontal direction, I'm going to be moving right or left. If I move one space to the right, I have a quadratic pattern, so that tells me that I'm going to be squaring my x value to get my y value. So y value is going to be vertical, so I'm going to be going up whatever 1 squared is. So in this case, 1. So from my vertex, I would go right 1 space, up 1 space. The next thing I would have, if I wanted to go 2 steps to the right, 2 squared would leave me with a y value of 4. So I'm going to go 2 spaces to the right, and then 1, 2, 3, 4 spaces up. If I wanted to go 3 spaces to the right, so 1, 2, 3, I would go up 3 squared, which would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, which puts me off the graph and gives me half of my parabola. Now to graph my other half, I would have to use symmetry. So I go left 1, up 1, left 2, up 4, and can just kind of reflect that over, giving me a parabola that looks something like this. So what I'm going to be able to see on this is that my graph has a smallest value. That smallest value, remember, is a minimum. It has a minimum at this location of 2, negative 2, negative 1. The next thing, my domain. We've discussed our domain for a quadratic is x is all real numbers. And so we use the double back r to represent the real numbers. Now our range, our y values, all of our y values in this are going to be larger than the minimum value. So I would say y is greater than negative 1, but it can equal negative 1 because that is our vertex. So I'd have to put less, greater than or equal to negative 1. So if I wanted to graph my second equation, the negative 2, x minus 2 squared plus 3, my vertex, I would see that I've got negative 2. I need to reverse the sign on that and make that a positive 2, positive 3. So I'm going to start at positive 2, positive 3 on my graph. My axis of symmetry would be x is equal to h, or in this case, the 2. The next thing I need to do is I need to graph my equation so I can determine if it's a minimum or a maximum. So I remember my pattern. I had right 1 on the x would be 1. If I wanted to go on my y values, however, this one's a little bit different. I have a times negative 2. So my y values need to be multiplied by negative 2. So if I go, so on a quadratic pattern, if I have 1 squared, this would be 1 times negative 2, which would be negative 2. If I had 2 steps to the right from my vertex, 2 squared would be 4. However, I need to multiply that by the negative 2 from the beginning of the equation, which would leave me with negative 8. So what does the negative 2 and negative 8 actually mean? Now I cannot go up -2. This is actually going to be implying that I need to go down 2 spaces. I cannot go up -8, so again this is going to be down 8 spaces. So from my vertex, my first part is going to be to the right 1 space, down 2 spaces. My second part would be right 2 spaces from my vertex, so going back to my starting point, going right 2, then I would go down 8. 1, 2, 3, 4, 5, 6, 7, 8. I would connect the dots. That gives me half of my parabola, and I would do the same thing going back the other way. So that's I'm going to be able to see now that this 2, 3 is going to be the highest point on my graph. So the largest value, my maximum, would be 2, 3. My domain, just like the last one, would be x, is all real numbers. My range, since this is my highest, that's my largest, all the rest of the y's are going to have to be smaller than 3. However, it does equal 3 at the vertex, so I need to put or equal to. Now, quadratic inequalities. You graph the equation, and then we have to check to see if it's true or false, and then color in the appropriate region. So my first equation, now remember 0 is, I can still have this be a y value. So I have 3x squared minus 24x plus 45 is greater than y. Now this I can see is in the factoring kind of format from the previous, from the unit 2. So I'm going to graph this the same way. I'm going to start by finding my x value using -b divided by 2 times a. In this case, b was -24, and a would be 3. So the double negative would make it positive 24 over 6, and 24 divided by 6 would be 4. Now again, since I have an x value, I would substitute it in for the 2 x values in the equation to find the y value. So I'd have 3 times 4 squared minus 24 times 4 plus 45. When I work this all out, I would have y is equal to -3, which gives me my first point of 4, -3. Now I'm going to follow the same kind of pattern that I used up here. I could factor it and determine my left and right positioning on the x-axis, or I could just follow the quadratic graphing pattern that we used on the last two, because we started at our vertex, and we can find our a value to do the same thing. So I'm going to go right 1 on the x-axis. So 1 squared would be up 1 point. So our y values, but we also have to multiply that by 3. So I'd have 1 times 3 would be 3. Sorry about that, the lights just flickered off. So I would go right 1, up 1, 2, 3. If I go right 2 spaces from the vertex, I would go up 2 squared would be 4 times 3 would be 12. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to run off the page. So I've just reflected on the other side. And I have my parabola. Now, when I find a test point, the test point could be any point on the axis of symmetry. Any point right on that middle red line. So we could pick 1 spot above it, we could pick 5 spots above it, we could pick a couple spots below it. It doesn't matter which point you pick. I would always suggest to stick on the red line because it's going to make your life easier in the long run. I'm going to choose this point right here. I'm going to choose 4, 0. So when I have 4, 0 as my test point, I'm going to substitute 4 in for x, and I'm going to substitute 0 in for the y value in my equation. So when I have that, I have 3 times 4 squared minus 24 times 4 plus 45 is greater than my chosen y value, which was 0. Now the reason why we always want to choose a point on the axis of symmetry is we've already worked this out. We know this is -3. -3 greater than 0. -3 is not greater than 0. It's smaller than 0. What that tells me is this little region inside the parabola, this whole little region inside the parabola is going to be represented by this one point, and this one point was false. So what that's going to tell me is the other side of the line is going to be my true area of the graph. And so since I would not color in here, I would have to color in the other part by default. Now there is one thing that we want to make sure we look at. It's the actual inequality. The actual inequality is just greater than. So there is one thing that we need to look at when we look at our graph. Our graph should have little spaces inside of it. So to kind of highlight the parts a little bit better, we would space out our line with little gaps. And that would be our first quadratic inequality. Our second quadratic inequality, we have 2 times x plus 1 squared minus 3 is less than or equal to 0. So this one's very nice. It's already set up like for us in vertex form. And I can already recognize my vertex would be -1, -3. So I'm going to continue my quadratic pattern of right and up. So my x, if I take one space to the right, 1 squared would be 1. If I go 2 spaces to the right, I would go up 4. If I went 3 spaces to the right, I would go up 9, and so on and so forth. However, this problem, like several of the others, has an a value in front. A value of 2 will multiply our y's. So 1 times 2 would be 2, 4 times 2 would be 8, 9 times 2 would be 18. So from my vertex, I would go right 1, up 2. From my vertex, I would go right 2, I would go up 1, 2, 3, 4, 5, 6, 7, 8. I would use, again, symmetry to complete the left side of my graph. This one will continue to use a solid line because we do have the or equal to part. Reminder, if it has a line in the inequality, our answer will have a solid line in the graph. So just like on the other one, I want to choose a value that's on my axis of symmetry. So I know my x value is -1, so I'm going to choose -1, 0. I'm going to substitute -1 in for x. I'm going to substitute 0 in for the y value. So I have 2 times x plus 1 squared minus 3 is less than or equal to y. Or 0 is less than or equal to -3, 2 times -1 plus 1 squared. Again, the nice part about the vertex, or using a point on the axis of symmetry, is -1 plus 1 would be 0. 0 squared is still 0. 2 times 0 is still 0. So I'm left with 0 minus 3. So -3 is less than or equal to 0. So -3 is smaller than 0. So what that's telling me is where my point was located at -1, 0 is true. What that's going to tell me is I need to color this side of the parabola when I fill it in, which is going to give me a graph that's going to show that all of the coordinates on the inside of this, in the red side of this parabola, would be a solution to this inequality. So a reminder, graphing quadratic inequalities algebraically, we are going to be dropping, and we will be readdressing this in the spring semester.